Well, it could be said that investigating materials is one of the most important things we could ever do in science. The whole world needs materials, and you wouldn't have any technological advancement if it wasn't for folks finding new materials or inventing new materials and using them for a particular job. And you think of space travel, hundreds of new materials and ways of processing materials have been developed because of the problem of going into space or under the oceans or whatever. So investigating materials, but let's stick to circuits. So that means it's something to do with electricity passing through them or not. So what circuit would we need? Well, the children can be challenged to come up with a circuit that can help us investigate materials by finding out which materials allow electricity to pass through them and which ones do not. So a common way to do that, you've got to have your materials, of course, and there are other videos I've done which relate to materials boxes. If you had a shoe box with just samples of lots of different materials you collect over a period of time, it would be very, very useful. I would recommend one for each little group of children, maybe one between three, a box, and you simply collect together very common materials. So that's a little piece of cement there, glass from the beach, no sharp edges, piece of copper tube. I've sanded off the edges of that one as well just to make sure there's no sharpness about it. Piece of cork from a bathroom tile. It just goes on and on and on. Materials can be investigated for lots of other properties apart from electrical, so it's always useful to have a materials box at hand. So let's pick some very simple things we could investigate. A piece of plastic, a piece of cork, a piece of wood, a piece of cloth. What's this here? A bar of metal. We'll say more about that later. Paper clip. It just goes on and on and on. You know, as many materials as you can comfortably work with in a lesson. And if each group had different materials, well, you could pool all the results at the end. So the first challenge is, which circuit would the children develop in order to find out if electricity travels through one of the materials? Well, somebody might just suggest clipping the ends there together and this end, but the material would have to be bigger, or you'd have to uproot the wire. But there's a fatal sort of flaw in that idea. If the material does let electricity travel through it, how are we going to know? We need some sort of visible, possibly audible sign. But let's go for a visible sign, and we know that a light bulb will light up if electricity flows through it. So why not incorporate it into a circuit where it's always present, therefore we assume it will light up if electricity flows through the circuit as a whole, and if that's the case, it must be flowing through the material that we're testing. So just to make life a little bit easier for ourselves, let's have an extra wire. Now we could simply hook in something like this and then miss out the switch. But if you want to be systematic about it, it's always good to have a switch in play. It just means that you can leave the circuit switched off and you know it's switched off each time, and then you've got the same starting and finishing point. So let's just check our circuit first of all. So without the material that we're going to test, we know that the electricity travels in the circuit. Now we can modify the circuit to allow us to test the material. So just to make life easy again, we've got another wire. We'll clip it to the other connection of the switch. Just rotate it around there. The wire's a little bit stiff. And now what we can do is place the material to be tested in between the two clips and see if the light bulb lights up. So we could actually clip it on. Here we go. There we are then. First material tested, a piece of red cloth. you might know what type of cloth it is, whether it's nylon or cotton or whatever it is. It looks as if, because the light bulb isn't lighting up, there isn't any flow of electricity through our circuit, so we can put this in a list, does not light the light bulb up, and we could call that list the insulators. So insulators are materials which don't let electricity travel through them. Now let's have a look at our next material and simply work our way through the list. Check, switched it off. There we are. Next one. Our paper clip is made of steel. Switch on. And it looks like, yeah, paper clips are metal. I suppose the clue is the crocodile clips are made of a metal material as well. That's most probably steel, which has been coated in another shiny metal like chromium or something like that. And the steel is allowing the circuit to be complete. So it must conduct electricity. So that doesn't go in the insulators pile, it goes in the conductors pile. So in that way, we can make a list of materials, conductors on one side, insulators on the other. I think the children, when they see the ones that light up, are much more sort of excited by that. So now they immediately search out all of the materials which they believe to be metals. So we might have, you know, a bolt. I've got these little rods here. This one's a copper rod and this one's a steel rod. Other types of paper fasteners. You know, you've all seen the little butterfly fasteners. They are ideal for this sort of thing as well. And here's an interesting thing to try. A pencil. Now I know we could say the pencil's made of wood, right? But it's really made of two materials, isn't it? And what I've done with that pencil is I've been very careful, and I've actually carefully cut it away so that it exposes the other material. And that, commonly call it pencil lead. Well, lead isn't used in pencils these days. It used to be, and people got poisoned by licking the tip in order to make them write better. But pencils are no longer made of lead. They're made of carbon in a special form called graphite. Now, we'll turn the light down and just see if we can get this to work. If we clip on, I'm just trying to make sure the teeth of the crocodile, turn the light back on momentarily there. The teeth of the crocodile have got to be able to clip onto the actual graphite itself. So just trying to make sure that happens. And then let's have a look. Let's just check we're switched on. There we are. We're switched on. And let's just check now. So can you see I'm deliberately moving them closer together? They're not actually touching, but the bulb is just flickering. So at that end, nothing. But right up, right up close. Right up close, but not touching. Come on, you can do it. There it goes. Tiny little gap of just a few millimeters. It does actually conduct electricity. So graphite's a very special material. It will conduct electricity. I suppose we could say it's not as good a conductor of electricity as those other materials. The wood should really be in that pile. So that's really, I think it's a sort of special case materials wise. And we'll come back to that a little bit later. Graphite. Fabulous.